Hello, I welcome you all to this another interesting screencast. The problem reads, if the force in each cable tied to the beam is 70 pounds, determine the magnitude and coordinate directional angles of the resultant force. And in the other case, we are being asked to determine the resultant. The resultant of the four cables given resultant force. If the resultant of the four cables is 316 pounds in the z-axis, determine the tension developed in each cable. Right. Both these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So due to symmetry around, about the z x-axis and the z y-axis, we expect the forces in all the cables to be equal. So let me write down this, and we've also been told down there. So due to symmetry, we expect force Fa equal to force Fb equal to force Fc equal to force Fd equal to F. Okay, right. So I'll show these forces so that we just appreciate this. Let our reference be E, and E is 0, 0, 0. Therefore, if we are to write down the position vectors, we expect REA, which is also equal to just RA, because E is our reference. We have assumed it to be our reference. This is going to be equal to, in the y-axis, we'll have a 3i, and then we'll have a negative 2j in the y-axis, and the minus 6k. So this will be the same, and not really, it will have the same numbers for the others. I'll just write all of them. You don't have to do this if you know already the symmetry. We'll have E what? I want to write those that are similar. ED, which is just also equal to RD. This also is just going to be equal to minus 3i minus 2j minus 6k, and then we have EB, okay, which is just also equal to RB, and this also is just going to be equal to 3i plus 2j minus 6k, and then REC. So we've seen the pattern here, which is also RC. This is also equal to minus, along the x-axis is minus 3i, and then plus 2j minus 6k. You see, they have the same values, okay? The same values, of course, and they will have the same magnitude. It's only the signs that changes. So if we are to write down the magnitude of each one of these, they will be the same because of symmetry. You expect the same forces in all the cables. Okay, so this I'm just showing. I should not have shown this. I could have just gone directly to calculating, but since this video is there to guide, I was forced to show. So 3 squared plus 2 squared plus 6 squared Of course, square root of that is 7. So we have 7s all over here. Alright. So if we are to write down the components of these particular forces, we have 1 in this direction in the x-axis. Let's say this one is coming from, FA. There will be another one from FB. Okay. Now I need to give it one color. I'll give it one color later on. So this one again is from MA in the vertical axis that is going down, and then we have another one in that direction, which is in the y-axis. Okay, something like that. So let's go to FB. FB will have 1 in this direction also. Alright, we'll have 1 coming down. Okay, then we'll have 1 in this direction. Okay, and then let's go for another color. We'll have another one in this direction. This is from either FD. We'll have another one going down like that, and we'll have another one for FD. We'll have one that goes that direction, and then we have the last but not the least. We'll have one again this side from FC. We'll have in this direction for FC, and we'll have one going down. So basically these are the forces. Let's label them. So for this one it is FA times the run along that direction, which is just a 3 divided by a 7, right? And then this one will be FA along that direction, it is a 2 divided by a 7. Okay, and then this one is FA, that's a 6 divided by a 7. So let's go to another one, green. So we said this one is FB, right? Yes, it is FB. So this one also, it is a 3 divided by 7. This one is FB. This is a 2 divided by 7. And then this one is FB, is a 6 divided by 7. Okay, then let's go to this next one. This one this one is FD. This is FD by 2 divided by 7. This is FD. This is 3 divided by 7. And then this is FD. This is FD 6 divided by 7. And then we have this one. This is FC 3 divided by 7. This is FC 2 divided by 7. And this is finally FC 2 divided by 7. I mean 6 divided by 7. Okay. If you know the symmetry, you don't have to do all this stuff, right? And when you look at this, you realize that this part will cancel out with this. When you start summing them up, this part will cancel out with this. The only resultant that will remain with it is this part here, right? The 4. Okay. Okay. So let me write down what I'm talking about. Let's go to the first case. Case 1, which is a 2-103. There we go. So what we're saying is, we know the resultant. The resultant is nothing but equal to the component from FA, force vector FA, plus force vector FB, plus force vector FC, plus force vector FD, and then finally we are saying we're going to have the resultant in these particular directions, like so. Okay, RY like so. Okay, like so. This is what we are saying, right? But we are saying this part will go to 0. Okay, this is what we are saying. They'll go to 0 because these are going to cancel each other out. All right, and so is this part. Okay, because of symmetry. The only part that will remain is just this component, and we've said they are all equal to F, and therefore we can write this resultant force is equal to F 6/7 minus 6/7 brackets. How many are there? There are 4. FA, FB, FD, FC, but we've said all these are equal to F, so there are 4 of them, so we'll say 4F. Alright, and we've been told that F is equal to 70 pounds. Therefore, F resultant is just going to be equal to, so 6/7 times 4 times 70. This gives us a minus 240k like so. Right. Okay. I think this is about it. Then there is this other part here to find the coordinate direction angles. We can also rewrite this particular force vector as equal to 0I plus 0J plus minus 240k. This is also the same thing. Okay. All right. And then the magnitude of this using Pythagoras theorem is just going to be equal to 240. All right, 240 pounds. Then we know that the unit vector R or FR is just going to be equal to the force vector itself divided by the magnitude, right? Then we know that cos alpha R will just be equal to FRX divided by the resultant, okay, magnitude of the resultant. Therefore, alpha R will just be equal to FR is 0, since this component is 0, so it is 0 divided by the resultant. Therefore, cos inverse of 0, we know what it is, right? It is a 90. So this gives us a 90 degrees. So the same applies to the other ones. Cos beta resultant is equal to cos beta resultant is equal to FRY divided by the magnitude. And we know that FR is 0, therefore this gives us 90 degrees. And then finally, cos gamma R is equal to FRZ divided by the magnitude. But we know that the magnitude, here we have a 240 minus 240, this component here, minus 240 minus 240 divided by 240. So minus 240 divided by 240 magnitude. So cos inverse of a negative 1 is 180. So gamma resultant there gives us 180 degrees. So these are the coordinate directional angles. Okay, right. So let's go to the second case, that is case 2, and this is 2-104. In this particular case, they've given us already the resultant. We have the resultant, the force vector equal to minus 360k. Okay, and this magnitude is the same value, all right, is 360 pounds. Okay, so this information we have. The question is determine the tension in each cable, but we know there is symmetry, so we are just using this equation here. We are just going to use this equation here. Okay, use this equation here. So we know there is we know that there is symmetry. Okay, we know the resultant is just equal to this value there. Okay, so how do we find this? We have a value there, and there we go. So we want to find this particular component. See this equation there. Okay, right. So there we go. Let's work it out. So we know that F R as this is equal to minus 6 divided by 7 by 4F, and then we are saying this is equal to of course here we should have a k there, right? A k like so. All right, so k, then we are saying this is equal to minus 360k. All right, so of course if we made F subject to the formula here, k and k cancels out, we'll find that let me lift this, I just bring it here. So if we made F subject of the formula there, you realize that F will give us equal to we make F subject to the formula, then you'll have minus and minus cancels out, and this is just going to be equal to 360 divided by 24 divided by 7. So this gives us a 105. We've just made F subject to the formula. Okay, so this is just 105 pounds. So this is the force in each cable given the symmetry. All right, I hope this video was helpful. And if it was, give me a thumbs up. Let me just outline. I just create a boundary there. I create a boundary like so, and then I outline the final solution like my customer has always been. So here we found the magnitude. We found the magnitude of the resultant force. Okay, we found the magnitude of the resultant force. Okay, as equal to 240. All right, as equal to 240. And then we also found the first vector. We found the first vector. There we go, something like that. Okay, and then here we found the force in each particular cable, given that the resultant is 360 in the z-axis. Alright, I think this is about it. I hope this video was helpful. Continue liking and supporting and sharing my channel. Bye bye, and see you in my next screencast.